Unit 3, this is lecture number 6. Here we will discuss about the controller structure Boolean expression, how to write it in intermediate code representation. Control flow. So translation of statement like such as if else statement and while statement is tied to the translation of the Boolean expression. Boolean expression are used to alter the flow of the control, compute the logical values. Boolean expressions are composed of Boolean operators such as AND operator, OR operator, and not operator. So it can be in the form of expression 1 relational operator, expression 2 where E1 and E2 are arithmetic expressions. So B can be Boolean expression, can be Boolean expression or Boolean expression. It can be Boolean expression and Boolean expression, or it can be not a Boolean expression, or it can be Boolean expression in the parenthesis, or it can be expression 1 relational operator, expression 2 true or false. The relational operator can be less than or equal to, not equal to, greater than or equal to. The three address code of control structure. Let us consider we want to write this for the for statement. So there is for statement for I equal to 1, I is less than 20, I plus plus, x equal to y plus z. See how to write. So first we can write I equal to 1. Then I can write I, if I is less than 20, then go to 4. So if the condition is false, then go to 4. So it will go out of the for loop. We can say that. Now in line number 3, I can write go to 9. So if the condition is false, then the it should go to 9. If the condition is true, then go to 4, and if the condition is false, then go to 9. So in line number 4, what we are doing, we are just evaluating x equal to y plus j, z, and to evaluate the x equal to y plus j, t2 equal to y plus j I can write, and then I can write x equal to t2. So the value of t2 is now placed in x. Now we need to increase the value of I. So to increase the value of I can write like this: t1 equal to t I plus 1, and this I can be updated by t. So now the I is updated. Now we need to go from here to the up location from the for is started. So I've written here go to 2. So from 2, it's this for is continued, and if the condition is false, we are going to line number 9. So 9 is the next, so it comes out of the loop. So this is the example of writing the for loop. Next we can have one more example. So it is little bit more complex example, but it's easy to write. If x is less than y, then go to 3, so that the for loop can be started. Otherwise we should go to line number 8. Line number 8, obviously it will implement the else part. So let us see how it can be done in. So now the body of if is started. If z is greater than d, then go to 5. Otherwise go to line number 11. So I can write t1 equal to a plus b, then a equal to t1, then I can then go to 3, so that this loop while loop is repeated, and then t2 equal to p plus q. So this is the do while part from the line number 8, and p equal to t2 I can write. So p is updated here, and while part is now implemented here. If e is less than 5, then go to 8, otherwise line number 11. So next we have three address code for the control structure for the while loop. So while loop we have AND operation, so Boolean operation is here. So I can write like this: if a is less than c, then go to 3. If the condition true, we are going at 3, and then if b is greater less than d, then go to 5. So it means that both the condition are true. Otherwise go to 15. Otherwise go to 15. In both the case, I am just writing that if one of the condition is false, then you will go out of the loop. So if a equal to 1, now this line number 5 is implementing the part body of the while loop. If a equal to 1, go to 7, otherwise go to 10. Next I am writing t1 equal to c plus 1, since this line is here. Then we can write c equal to t2, so that the c can be updated. And now else part should be implemented because of this part. So I have written here if a equal to 1. So if a equal go to 7. So we need to go to the 7 part if the condition is true. Otherwise go to 10. So for line number 2, else part is implemented. So now go to 1. It's very simple to understand. I think you can trace it like in the same way. Next we have short circuit code. So for the short circuit code, you can see, or jumping code, the Boolean operator and operator not operator can be implemented. And if x is less than 100, or if x is greater than 200 and x is not equal to y, then x equal to 0. So I can simply write if x is less than 0, we do not need to see other parts. So we are going to the L2 location. So this L2 location here you can say L is equal to 0. Direct we are just jumping here. So, and rest of the part is then go to L. If second part is also then go to L1 and it is the out of the part. So it's very simple to implement. Flow control statement. Related grammar can be statement can be if Boolean expression S1, if statement can be if Boolean expression S1 else S2, Boolean expression S while we. So one by one I will discuss. So S can be if B then S1. So B dot code can be here written at this location to B dot true to B dot false. And for the if else part you can see here for if dot true if it be dot false s dot code is here, go to s dot next so that we can jump from here. This is statement we have. Next for the while loop we have here go to begin, so this loop is executed. It's very simple to understand. Next we have one more example. Consider example we need to write if x is less than 100 or x is greater than 2, and so implement it. What we can do, we can write if x is less than 100 then go to L2, go to L3. So we are coming here at L3 if the condition is true, and we are checking whether the x is greater than 200 or not. Otherwise go to L4. So it's very simple to implement here. Control flow translation for the simple if statement. This one is an example. 3 address code for the Boolean expression. One more example I am just taken. For a is less than b or c. So if a is less than b then go to 4, which indicates that a is less than b actually, otherwise t1 is 0, otherwise t1 is 1. Go to 5 from here, and what I'm doing, t2 equal to t1, so t1 is placed at t1 and or operation can be done here. Next one more example for the AND operation. If a is less than b then go to 4, otherwise t1 equal to 0, go to 5, otherwise t1 is here, t1 value of t1 is 1, go to 8, t2. So for both a is less than b, c is greater than d, t1 and t2 is now ready. Now we can write t3 equal to t1 and t2. So AND operation is here implemented and the result is stored in t3. So one more example we can take here. A is less than b and a is less than, so 3 AND statement is here. So if we are not considering the shortcut statement, so we need to implement all the part. Short circuit statement is not implemented here, it is implemented the complete part. So we may use the short circuit statement because if one of the condition is false, and since all there is AND, so we can jump directly to exit from the part. Otherwise we can implement each and every condition. A is less than b, c is greater than d, e is less than f, and so on. So it's very easy to understand. If you go through each and every line you will understand.